So we're looking at midterm solutions for MAT230. We're asked to graph this function and discuss continuity at a point specifically. We see that the function is defined on all real numbers, to the left of 2, 2, and to the right of 2. I'm using the symbols of the bracket between negative infinity and 2, and the parenthesis for greater than 2. In this interval, I'm using 2 minus x. For this interval from 2 to infinity, I'm using x squared minus 4x plus 4, which is the same with x minus 2 squared. I plug in 0 in this expression and I get 2. I plug in 2 in this expression, I get 0. I plug in 2 in this expression, I get 0, and I plug in 3 and I get 1. I know that this is a quadratic function opening up, and this is a linear function. So 0, 2 is this point, 2, 0 is this point, 2, 0 is this point, and 3, 1 is this point. This side is a straight line, and this side is a quadratic function. Continuity at a point definition is a limit from the left equals limit from the right of the point equals f of the function value at that point. The function is continuous on negative infinity to 2 as a polynomial, and it's continuous on 2 to infinity as a polynomial. Now continuity at x equals 2. The limit from 2 minus x is equals the limit from x minus 2 squared when x approaches 2 from the left and then 2 from the right, and it equals f of 2. But for that reason, the function is continuous at that point. We were asked to determine the derivative using the definition of the derivative. So that means this is the definition, and also we were asked to find the derivative using differentiation rules. I started with that, the top function prime times the denominator minus the top times the denominator prime over the denominator squared. I distribute 6x minus 4 and then minus 6x minus 3. These two go away, minus 7 over this. So this is what I should expect from the limit of the difference quotient, which is the formal definition of the derivative. So I write the definition, and then f of x plus h is 2x plus h, or 2x plus 2h plus 1. In the denominator, we have 3x plus 3h minus 2, and then minus the original function divided by h. The least common denominator is the product of these two, and this is h over 1 that will be flipped into 1 over h. So this becomes the denominator. But now I have to multiply 3x by, because this was multiplied by 3x minus 2, and this was multiplied by the other one, 3x plus 3h minus 2. So now let's see. This is 6x squared, and then 6xh, and then 3x, and then minus 4x, and then minus 4h, and minus 2, and now minus 2h times 3x, minus 6xh squared, minus 6xh, and then plus 4x, and then negative 1 times 3x, negative 1 times 1 times 3h, I ran out of room, sorry about that, and then plus 2. So all terms have to go away. Those who do not have h must go away, and some terms with h may go away, but that's not mandatory. So 6x squared with negative 6x squared, 6x with negative 6xh, 3x with negative 3x, 4x with negative 4x with positive 4x. This is left, negative 2 with positive 2. So everything that is left is a negative 3h with a negative 4h. So that's negative 7h. We will simplify with h in the denominator. That's the second thing that has to happen. And now when I apply the limit as h approaches 0, I get this. Exactly what I obtained with the differentiation rules. For this function, we were asked to find its domain. I factored completely, and the denominator cannot be 0, so x cannot be 9, x cannot be negative 1. So in interval notation, from negative infinity to negative 1, union negative 1 to 9, union 9 to infinity. For this function, we were asked to find the average rate of change between the given points with x is 1 and y equals 5. So when I plug in 1, I get y equals 1. When I plug in 5, 10 minus 1 is 9. The square root of 9 is 3. So y2 minus y1, 3 minus 1 over x2 minus x1, 5 minus 1. The numerator is 2, the denominator is 4, simplified into 1/2. Question 5, we were asked to determine these limits. So the limit as x approaches 2 from the right, I see it's 0 over 0, so there is hope. So I factor x squared minus 4 into x plus 2x minus 2. I simplify the factor that creates the problem, the 0 over 0. And now the numerator goes to 1, the denominator is 2 plus 2, 4 times 2 is 8, 1 over 8. Limit as x approaches 0 from the left of 10 over x. There is absolutely no way it's 10 over 0. This limit does not exist, but I cannot write d and e. I have to plug in a number from the left of 0, and I get negative infinity. Last limit, I see it when I plug in 1, I get 0 over 0, so I will be using L'Hopital's rule. The numerator differentiated is 12x squared plus 3. The denominator differentiated is 2x. I continue plugging it in, and I get 12 plus 3, which is 15, divided by 2, 15 over 2. Question number 6. We're asked to differentiate and fully simplify. So 3 times 2x minus 3 to the second power times the inner function prime times the second function plus the first function times the second function prime, 4 in front, 3 minus 5x to the third power times the inner function prime, which is negative 5. I will reorganize 3 times 2 in front, 6, and I copy these two. And then 4 times negative 5, negative 20, and I copy these two. Now I realize that 2 is a common factor, 2x minus 3 is a common factor, and 3 minus 5x is a common factor. Let's see the powers. 2 is the smallest power, 2 is out. 4 and 3, 3 is the smallest power, 3 is out. So from this, what is left? A 3 in front, 2x minus 3 squared is out, 3 minus 5x to the fourth, I have 3 out, so 1 is left inside, minus 10, because I have a 2 in front, and that's negative 20, so minus 10. This is completely out, and then from 2x minus 3 cubed I have 2 out, so I have left 1 inside. I will distribute to simplify this, so this is 9 minus 15x minus 20x and plus 30, and when I combine these I get negative 35 and plus 39. So I have negative 2 because I will factor out negative 1. I will copy this factor, I will copy this factor, and my 35x minus 39. Problem 2 in 6, differentiate, bring negative 4 in front, subtract 1 from the power, and differentiate the inner function, 3x squared minus 3. Or rewrite it as negative 4, 3x squared minus 3 divided by this to the 5th power. The next one, differentiate a square root, 1 over 2, the square root, times the inner function prime, which is 8x cubed minus 23. Or, written it condensed, 8x cubed minus 23 at the top to the square root in the denominator. Differentiate implicitly to find dy over dx. This is the product rule. First function prime times the second one. The first function prime is 1 times the second one plus the first times the second one prime. This is just a function of x. Differentiate 6x squared. But this is the chain rule with the power rule. So I bring down 2, so it's negative 6. I subtract 1 from the power, and I differentiate the inner function, which is dy over dx. I differentiate 4, I get 0. I factor out from these two, I get x minus 6y, and I move these two terms to the other side. They both become negative, so there is a negative in front. So then dy over dx is this over this. Here we're given a problem to find certain questions, to answer certain questions about the number of words memorized per minute. So the rate of change is this. Multiply, bring down 3, multiply, subtract 1 from the power, bring down 2, subtract 1 from the power. We were asked to find the number of words memorized at the end of 15 minutes, so just plug it in, and I got 19 words. And now the rate of change after 15 minutes, so we plug in this time 15 in the derivative, so we get this. Don't forget the measurement unit words per minute. We were asked to use differentials and approximate 119, and this is the formula, f of x plus f prime of x dx. The function is the square root of x. Its derivative is 1 over 2 the square root of x. The actual number is 121, and the minor error is negative 2. So then 119 is approximately the square root of 121 plus 1 over 2 the square root of 121, and times dx, which is negative 2. So this is 11, this is 1 over 11, but the 2 go away by simplification, minus 1 over 11. So 121 minus 1 is 120 over 11, and that's final. I don't need to do anything else here. Here we're asked to graph this function presenting absolutely everything. So I found the domain of the function is polynomial. I find the limits left and right, not left and right, sorry, at infinities. So this is the most powerful term at infinity. So when x approaches negative infinity, the function approaches negative infinity and respectively infinity. The first derivative, 3x squared minus 12x, when I set this equal to 0, I get two solutions, 0 and 4, because you factor out 3x. 0 and 4 are critical numbers, so I put them in the table, 0 and 4. I determine immediately the function value at that point. I plugged it in, and I got negative 22, and I got here 10. So f of 0 is 10. So f of 0 is 10. And also I found the rest of the x-intercepts. I solved this equation with the calculator, and I got these three solutions. So negative 1 over 2, comma 0, 1.5, comma 0, 5.7, comma 0. I also found the second derivative, and 6x minus 12, so I get x equals 2, so 2, comma 0. I study the sign of the first derivative, and here, in between its solutions is negative, which can plug in a number, and you will see here it's positive. And the two rows work perfectly together. So increasing from negative into 0 and further to 10, yes. This is a local max because the sign change of the derivative. Then it's negative, yes, it's decreasing, the derivative is decreasing, the derivative is negative, the function is decreasing, from 10 to 0 to negative 6 to negative 22, perfect. And then it starts increasing to 0 and infinity, so that's positive, that's correct. So these are local max and local min, and now the second derivative, 2 comma 0, 2 comma negative 6, when the second derivative is 0, this is the IP, inflection point. You study the sign of this expression. To the left of 2 is negative, to the right is positive. So it's opening down, concave down between negative infinity and 2, and concave up between 2 and infinity. So based on the table, I plotted the points that I had in the chart, and it increases to a relative max. It's decreasing to the point of inflection, changes concavity, it gets to a to a relative min. There is no absolute, and it goes to infinity. And this is the function x cubed minus 6x squared minus 10 plus 10. Here we were asked to study the function on the closed interval. So first I kept 4 outside. The first function prime is 1 times the denominator minus the first function times the denominator prime. So then 4 stays outside, negative 2x squared plus x squared is negative x squared plus 1, factor of negative 1, and factor the numerator. So the critical numbers are negative 1 and 1. The interval is negative 3, 3. So I plugged in the function negative 3 and I got this. I plugged in the function negative 1 and I got this. I plugged in 1 and I got this, and I plugged in 3 and I got this. Now I'm testing that these two rows work well together. From negative 1.2 to negative 2, yes, that's correct. From negative 2 to 2, yes, that's correct. From 2 to 1/2, yes, 1.2 is correct. So nothing, absolute or relative minimum, absolute and relative max, and nothing. Here we're asked to determine the marginal revenue. So we determined the revenue as the revenue minus the cost, and x squared minus 1.1 x squared is this. 110x minus 10 is 100x, and 60 minus 80 is negative 20. I differentiated. I set it equal to 0, and I got x equals 500. And we were asked to find the maximum profit, not just the marginal profit, also the maximum profit. And this is a typical situation because if you plug in 0 here, you will get positive, and outside after that is negative. So this is typical for a maximum. How did I get the 24,980? I replaced x by 500 in the original function profit. Final question. We were asked to determine the cost. We were given a cost function for 40 units. I plugged it in and I got this. For 42, I plugged it in and I got this. And the difference, the exact difference in the cost is CO42 minus CO40, and I got this. Then I was asked to find the marginal cost, bring down 3, plus multiply, subtract 1 from the power, multiply by 2, subtract 1 from the power, and 19x prime is 19. We were asked to determine the marginal cost for 40, and that's what it is. And then we were asked to use differentials to determine the cost for 42 using the cost of 40. So CO42 is CO40 plus 2. And from the formula that we used on a previous problem, CO40 plus C prime of 40 times 2. And CO40 is this, C prime of 40 is this, and 2 is 2. Calculate, and you get 1,694.80. Thank you.